abrasive jet machining or AJM. In AJM, a high velocity jet of dry air, nitrogen, helium or carbon dioxide, which containing abrasive particles is aimed at the workpiece. The impact of these particles at high velocity on the surface of the workpiece produces sufficient force to cut the required shapes. The AJM process works on the basic principle of abrasive erosion, and the metal removal takes place due to brittle fracture of materials and also due to micro cutting by the abrasive particles. The setup is shown in this diagram. High pressure gas is supplied through filters and dryers. The filter is used to remove the dust and other suspended particles from the gas, and a dryer is also used for removing the moisture contents. The dry clean gas is then admitted to the mixing chamber where abrasive feeder feed abrasive in it. The abrasive size is about 50 microns in size. Then this high pressure gas plus abrasive is expands through a nozzle where the potential energy is converted into kinetic energy. So we will get a high velocity gas plus abrasive mixture through the nozzle, and the velocity is around 200 meter per second. Now this high velocity abrasive particles are made to impinge on the work surface, and the material removal is happening with micro cutting and brittle fracture mechanisms. The performance of AJM process depends on four process parameters as shown in this fishbone diagram. The parameters are work material, nozzle, abrasive, and gas. In work material, we consider its various types of work materials. In nozzle, the material, its geometry, feed rate, and standoff distance, that is the distance between the nozzle and the workpiece. These are the factors. Then in abrasive, we are considering its strength, type, size, mass flow rate, composition, etc. And finally, in gas, we consider the composition, velocity, and pressure. When the gas jet in an AJM process is replaced with a water jet, then it is known as abrasive water jet machining or AWJM. In this process, the mechanical energy of water and abrasive phases are used to achieve material removal or machining. The mechanism of metal removal in a ductile workpieces, it is erosion due to shearing action, and for woody materials it is crack initiation and propagation, or otherwise it is the brittle fracture or failure. The setup is shown in this diagram. The main parts includes an intensifier pump which pressurizes the water to a high pressure ranging from 2000 to 4000 bars, and this high pressure water is stored in an accumulator, and in order to reduce the pulsating action of the water pumping, then this pressurized water is admitted to a nozzle through an orifice, and in the nozzle has got mixing chambers, and where it is mixed with the abrasive particles, and then when it is passed through the nozzle, its potential energy is converted into kinetic energy, and the velocity of the jet will be around 800 to 1000 meter per second, that is around 2.5 max. And the this high velocity abrasive plus water mixture is capable of cut almost all materials. The nozzle contains two parts. So one is the mixing chamber where the abrasive particle is get mixed with the water jet, and then it is passed through and the second part known as the focusing tube. So the focusing tube is made of a hard material of tungsten carbide in order when it since it is subjected to high wear rates. And the focusing tube diameter is made between zero point 0.8 to 1.6 mm, and the length is around 50 to 80 mm. The sketch shows the cross section of the nozzle in which, sorry, sectional view of the nozzle in which the orifice, then the mixing chamber, focusing tube, and the nozzle cover are shown. And finally, it have a catcher which is used to absorb the residual energy of the water jet and dissipate the same, because that is has to be contained because after machining this abrasive particle has got a high energy, so that should be contained, otherwise it will damage to the machine parts or the operators. So there are three kinds of catchers are used. One is the water basing type in which water is used to absorb the abrasive jet. In another case, the second type is a steel or tungsten carbide or ceramic molds are used. And the third one is we are using catcher plates made of titanium diboride. So these plates, when it is hitting with these plates, its velocity is made to zero. The process parameters of Awjm includes the orifice size, then the focusing tube sizes, the pressure used, then the abrasives used, abrasive flow rates, standoff distance, SOD, then machine impact angle, then transverse speed, that is the feed rate, then depth of cut, etc. Thanks for watching.